Hello friends, welcome to my new video. In this video we are going to see hybrid electric vehicles. This is the overview of the PPT. Before moving towards the hybrid electric vehicle, we will first see what is an electric vehicle. It is the vehicle which is propelled by the electric motor by using the energy stored in the battery. Now we will see why we need EV. Because the oil reservoirs are depleting day by day, and due to this depletion the automobile manufacturers are in search of finding an alternative for the conventional vehicles. Then the oil production and consumption rate is very high. Due to this there is increase in pollution and fuel prices are hiking day by day. Now we will see the components of battery electric vehicle and then we will discuss their functions. It consists of a charger, rechargeable battery, drive control unit, inverter, electric motor and transmission unit, means the gearbox. First we will see the function of the charger. The function of the charger is to take the alternating current from the power grid and charge the battery. Then the second component is the rechargeable battery. This rechargeable battery stores the energy and gives to the drive control unit when it is required. This drive control unit is used to regulate the amount of current flow which is to be passed to the electric motor through the inverter. Then it consists of an inverter which is used to convert direct current into alternating current. This alternating current is further used to run the electric motor, and the revolutions of the electric motor are converted into required amount of torque or speed. This amount of speed or torque achieved in the transmission unit is further passed to the to run the wheels. Now we will move towards the advantages of electric vehicle. There is no pollution. Then it has less or negligible noise. Then there is rapid acceleration, low running cost and low maintenance cost. Now we will move towards the disadvantages of electric vehicle. Electric vehicles has limited traveling range. Then the charging infrastructure are not developed in the village areas. Then the initial cost of the electric vehicle is high due to high manufacturing cost of battery. Then battery has short lifespan. Now we will move towards the main part of this PPT, which is the hybrid electric vehicle. Hybrid electric vehicle is the vehicle which is propelled either by the electric motor, IC engine or combination of both can be used for propulsion. Now we will classify the hybrid electric vehicles. There are three modes of classifying the hybrid electric vehicles. First, it is based on architecture. Then second mode is based on degree of hybridization. Then third is based on nature of power source. So first we will classify based on architecture. There are three types: series hybrid, parallel hybrid and series parallel hybrid. In series hybrid, the only way to provide power to the wheels is by the electric motor. This electric motor receives the power either from the battery or from the generator which is run by the IC engine. The quantity of power to be taken from the generator or from the battery is decided by the computer assisted drive control unit. Now we will see the power flow in the series hybrid electric vehicle. There are two types of power flows, first from the battery and second from the IC engine. The power from the battery is given to the drive control unit. Then it is supplied to the inverter. Then inverter supplies the power to the electric motor. Then this electric motor gives the power to the transmission unit. and at last the transmission unit gives the power to the wheels. Then we will see the second power flow type, which is from the IC engine. The IC engine generates the power in terms of rotations. These rotations are used to rotate the generator, and the electrical energy produced in the generator is given to the drive control unit, and the further power flow is as same as the battery power flow. Now we will see the second type based on the architecture, which is parallel hybrid electric vehicle. The parallel hybrid electric vehicle, the power is given to the wheels directly from the IC engine or from the battery. When power requirement is low, that time the excess power produced by the engine is given to charge the battery, and during the braking operation the electric motor acts as a generator and uses the regenerative braking energy to charge the battery. Now we will see the power flow in parallel hybrid electric vehicle. In this also there are two types, first from battery and second from IC engine. The battery power flow is given to the drive control unit, then to the inverter, then it is given to the electric motor. Then this electric motor gives the rotations to the transmission unit, and this transmission unit further passes the required amount of torque or speed to the wheels. And second power flow is directly from the IC engine. The IC engine directly gives the rotations to the transmission unit, and further the power is passed to the wheels. Now we will move towards the third type based on the architecture, which is series parallel hybrid electric vehicle. In this series parallel hybrid electric vehicle, it has the combined advantages of both series and parallel hybrid electric vehicle. On low speeds, the vehicle runs as the series hybrid electric vehicle, and on high speeds, the vehicle runs as the parallel hybrid electric vehicle. In this series parallel hybrid, we will not see the power flows because we have already seen the power flows for the series hybrid and the parallel hybrid. We will just check the series connections and the parallel connections. In this there are two series connections and two parallel connections. First we will check for the series connections. The series connections are from the battery to the electric motor. Then this electric motor is gives the power to the transmission unit and to the wheels. Then second series connection is from the IC engine to generator to inverter to electric motor to transmission unit and to the wheels. So by moving forward we will see the parallel connections. There are also two parallel connections, first from the battery to the electric motor to the transmission unit and to the wheels. Then second parallel connection is from the IC engine to the transmission unit to the wheels. Now we will classify the HEVs based on the degree of hybridization. Degree of hybridization is the ratio of the power of electric motor to the total power, which is the electric motor power plus the IC engine power. The formula for the degree of hybridization is given below. There are four classifications based on degree of hybridization. First is microhybrid. In microhybrid, the degree of hybridization is up to 5%. Then second is mild hybrid. In this mild hybrid, the degree of hybridization of the vehicle lies between 5 to 10%. Then the third type is full hybrid. In this full hybrid, the degree of hybridization of the vehicle is about 10%. But there are two categories in full hybrid. For the parallel hybrid vehicle, the degree of hybridization ranges from 10% to 50%, and for the series hybrid vehicle, the degree of hybridization ranges from 50% to 75%. The fourth type of based on degree of hybridization is full electric vehicle. In this, the degree of hybridization is 100%. At last, we will classify the HEVs based on the nature of power source. There are two types: IC engine powered HEVs and fuel cell powered HEVs. As we have seen, the IC engine powered HEVs, there are three types: series hybrid, parallel hybrid, and series parallel hybrid. And in fuel cell vehicle, there is a hydrogen fuel cell in which the combustion of hydrogen gas takes place and the generated power is given to run the vehicle. Thanks for watching this video, and if you enjoyed this video, then like my video, subscribe my channel and share this video with your friends.